In our previous tutorial, we built an event source system to handle user registrations. You could call this microservices or service-oriented architecture or distributed systems, but it was a simplistic example only. Really, we only collected email addresses. Now we want to do something with those email addresses. In this two-part tutorial sequence, we'll start expanding on our event source system and build a completely new feature. Welcome emails. We'll be sending emails to all users who have registered through our application. But before we mess with any event source components, we need a mechanism to send emails to our users. Now we could use net SMTP from the standard Ruby library, but I prefer using the mail gem simply because its API is easier to grasp. But even with that, it's still better to write our own classes that encapsulate the logic of sending email, even if we're using other libraries under the hood. This way we can control the interface, behavior, observability, testability, and so much more. However, sending emails is what we would call a destructive side effect. It affects a change in a system outside of our control. Think of things like I/O, inserting tuples into a database, or charging credit cards, etc. Those kinds of side effects. Of course, when we're testing, we don't necessarily want to actuate these side effects. We don't want to send real emails to real people. Not only would this be annoying to those very real recipients, you could damage your ISP reputation significantly, either from sending spam to real people or because the emails you're sending aren't actual inboxes and therefore the messages bounce. Both of these activities could cause your ISP reputation to drop, meaning your emails will more likely end up in a spam box somewhere. Not good. Therefore, during development, we need to control our email, i.e. control our mail server. For this purpose, I like to use MailCatcher. It's an SMTP server used for development. It will catch all messages sent to it, and it will display those messages on a local HTTP server. Now, what I like to do is create a Docker container for a MailCatcher. So let me go ahead and set up a project repository. So I'm going to create a directory. And let me go ahead and initialize the Git repository. And let's create a README. And a Docker Compose file. Let's do some boilerplate first. And let's define our mail server container. The image we'll be using is MailCatcher. And we need to define our ports. We'll be exposing port 1025, the SMTP port, and port 1080, the HTTP server port. Let's go ahead and spin up this Docker container. And let's take a look at the HTTP server. We don't see any emails yet, but this is where we'll be doing most of our interactive testing. Now we have a mail server we can send messages to without fear of damaging our ISP reputation. Next, we want to create an SMTP email library. So let's get started. I'll go ahead and create a new project directory. And this part's a bit boring, so I'll go ahead and set up the project skeleton and check back in a few minutes. All right, I'm back. Let me go ahead and explain a few of these files. Some of this will be familiar if you caught my earlier tutorial. We have our gem spec, which I've included the mail gem here. And of course, we have our install gems script, our load path, and our test directory, where we have automated and interactive testing. Now let's go ahead and install our gems. And now let's go ahead and create a rudimentary SMTP email class. First, we're going to create our loader file where we will require the mail gem or library. Next, we're going to go ahead and require the SMTP email class, which we'll put here. And let's start with some boilerplate. This will all seem very familiar from my earlier tutorial. Okay, we have our boilerplate. Now let's go ahead with our message signature. We want a call method to accept a to address and a from address and our message's subject and body. Now we want to construct a new mail object, and we want to define some settings. This is going to be our SMTP server. And we pass this in as an SMTP delivery method to the mail object. Now let's go ahead and assign the method signature to the mail object. And now we'll deliver the message. And this is pretty much it. Now we want to test this, of course. So let's go ahead and do some interactive testing. But before we do that, we want to define some controls. We create controls in order to have first-class exemplary data and objects. Let's define an email control. And with that, let's get the boilerplate out of the way. Okay, let's go ahead and define some data here. First, we have our to address. This is going to be the recipient. Then we have our from address, which will be the sender. Then, of course, we have our subject. And our body. And that's it. Now we want to define a control to send email in order to actuate this. So let's go here. And define it again here. Let's go ahead and change this. I'll just copy all of this to... All right. I'm just copying some boilerplate so I don't have to redo everything. Okay, so I have the boilerplate done. Now we want to define our call method. And then let's go ahead and put in the arguments. We're going to want defaults, of course. And our defaults will be the ones we just defined. And of course, now we want to actuate the SMTP email object that we just created and send the email. Next, we want to create an interactive test. We'll need to require the interactive init file. And we want to define some arguments that we'll be passing in. Let's go ahead and make these a little bit different from the test controls. And actuate the test control. Okay, let's go ahead and test this. The great thing about interactive tests is that they're just Ruby scripts that we can run. Okay, so we seem to have run into our first problem, which is that we haven't initialized the constant controls. And the problem is that our test init file doesn't have controls defined. So let's go ahead and do that. All right, that should be good. And let's try again. Oh, right, I need to actually require the controls loader file, which we'll do right here. Let's go ahead and test that. It looks like everything went well. Let's go ahead and check MailCatcher. As you can see here, we have a mail from john@example.com to jane@example.com with a subject of hello and a body of how are you today? This is a test body, which is what we expected. So we've created a class that will send email, but there are some problems here. Well, not problems exactly, but a few areas for improvement. For example, the values for our SMTP server are hard-coded in. The class isn't controlled. Sometimes we need to render a class inert so that it won't execute any destructive side effects, say when we're testing our code. Another problem, we can't observe the internals of the code's execution. It would also be nice if we could add some logging so that we could observe what's going on during runtime. Actually, let's go ahead and add logging next. We'll go ahead and add the EBT logging library to our gemspec file. And now we'll go ahead and install gems. Oops, sorry. The correct package name is EBT log. And we'll reinstall gems again. There we go. Okay, so let's go ahead and add some logging. First, what we need to do is add a log class here. And this is going to be a subclass of the log class. And we need to define a tag method. And what we're going to do is add a tag called SMTP email. What this does is allow us to specify which tags we want to see during runtime. As you can see, when we go to our interactive init file, you can see we're defining log level and log tags. This is where the tags come in. Right now we have all tags set, but we could just as easily just see the SMTP email tags. Right now we have only one set of tags we're looking at, so I just set them to all. Now we go back to our email class and we include the module log dependency. And with this inclusion, we can go ahead and start logging things. What I like to do is log both before and after a certain thing is done. So some sort of important action that needs to take place, I want to go ahead and log that, say sending email. So we'll do it before. And we want to go ahead and see what we're logging. So right now we'll just do the to and from email addresses and the subject, and we won't worry about the body. So this is the before, and of course we want to log the after. But we're going to make this a debug log, and we're going to say that it was sent. Additionally, I want to log the settings for the delivery method. And we'll go ahead and tag this delivery method. With the settings. Excellent. Let's go ahead and see this at work. We'll go ahead and run our interactive test again. Oh, that's right. I need to require the log library. Let's try that again. Now, if we look at this, we're only seeing the debug log level. My log levels may need some adjustment. So let me go here and change this to trace. Whoopsie. There we go. Let's try this again. And there we go. Now we see all of the logs that we added. We can see that we are building the delivery method with the settings for address localhost and port 1025. We can see that we're sending email with our arguments and that we sent the email. Next, we want to make it so that the SMTP server isn't hard-coded into the package. We'll be using the settings library from Eventide to manage this. Let me go ahead and add the settings library. And let's go ahead and add settings here to our loader file. And let's install gems. Next, we want to build a settings file. So let's go ahead and add one here. And add one here. Whoops, I seem to be having some trouble today. There we go. Okay, let's go ahead and change this to settings. And we need to set this as a subclass of the settings class. Next, let's go ahead and define a singleton. And set our data source. This is going to be a file where we can usually find our SMTP settings. And I'm going to set a module with that file. Okay, let's go ahead and add a settings SMTP email.json file. And let's git ignore that. And we want to create a copy of this for an example file. I don't know what that was. Oopsie. So let's go ahead and define our settings with an address of localhost and a port of 1025. And we'll copy this and paste. Okay, now that we have our settings class, we can use this to set attributes on our email class. Let's go ahead and include the settings setting module and define some settings. Then we go ahead and set our settings through our build constructor. And of course, now we're going to use our singleton method and set them. Whoopsie. Now we need to replace our hard-coded values with the ones from our settings. All right, let's go ahead and see if this works. Uh-oh. I see what happened. We just needed to add an S here. All right, let's test this again. And it looks like, if we look at the settings we set here, that it went ahead and worked. Now, something that we want to be able to do is pass in settings into this library, because we don't want to use the settings defined here. This is just the default settings that we're using to test, but any packages that consume this library will have their own settings. So we need to pass in settings into the factory methods for this class. So for this build method, we'll need to pass in settings. And I don't think we need to edit much else here because if settings is nil, we default to our singleton method. Otherwise, we use the settings that we passed in. Likewise, for our configure factory, we need to define a settings attribute and pass them into the build factory. And that should be it. Now that we've configured our settings, we can go ahead and move on to creating the class's substitute. Now, the reason we use substitutes is to help us manage our dependencies. A substitute is a class that has the same interface as the parent class. It has the same interface and the same contract, so on and so forth. We use this so that we can substitute operational implementations with inert ones. Operational implementations will have destructive side effects, whereas inert substitutes will be the same as a no-op. All we want them to do is record their own telemetry so that they can be inspected later on, perhaps during testing. So let's go ahead and do that. We'll create a substitute here and add it to our loader file. Let me go ahead and grab some boilerplate. Okay. So what you need to know and understand is that when the SMTP email package is used as a dependency, the dependency module will search the class for a substitute module, like this one. If this exists, it will use the build factory method inside the substitute module in order to construct its null object. Otherwise, it'll just use a default null object. And of course, this has all been demonstrated in a previous tutorial. And inside our substitute module, we want to define a subclass of our parent SMTP email class. And this one will have its own build factory as well. Now we want to be able to use this as an inert substitute for our parent class, which is right here. So given the relationship between parent class and subclass, it will inherit all these methods. And we want to replace the subclass's method with something that will be inert. So what I like to do is create a new method called, say, send email. Call that here. This is in essence just a delegate. And then inside the substitute, replace that method. And it has to have the same signature. And then just don't do anything. Next, we want to add telemetry to our class. Now, telemetry is an important use case, for it provides an insight into the execution of the class. Certain mocking libraries put this functionality in after the fact, but coding it in directly, I think, makes the telemetry more transparent and removes any obfuscation. Here we're using Eventide's telemetry package. And note that it's not required that we implement this, but it provides many useful things for us, including observability of the class during automated testing. So I'm going to add the telemetry library to our gem spec. And we'll add it to our loader file. We will also need to add the dependency module here in order to add dependencies. And we want to set a dependency for telemetry with the class telemetry. Actually, we want to set it with the base class. Okay. We also want to create a separate telemetry file here. There we go. Okay, we've got some boilerplate. Now we want to define our own telemetry module, inside which we want to define a sync class. Here we include the telemetry sync module. And we're going to be using the record macro in order to signify which signals we're looking out for. in this case, the sent signal. Then we'll define a sync singleton. And then I think we're going to want a data class thing that will be a struct that will accept to, from, and subject. What we'll use this for is to record what is sent through to our telemetry sync. Okay, let's go ahead and define some tests now. We're going to require our automated init. And then let's set up our test. So we want to grab the substitute. Oh, something I forgot to do is to define a method to register our telemetry sync. So let's go ahead and do that. So within this module, we want to define, actually not within this module, outside of this module, we want to define a register telemetry sync method. And it will accept one argument, which is the receiver class, or the receiver object, sorry. And what this does is, we take our sync, and then we register it with the receiver. And then we return the sync. And then within our substitute, we go ahead and register our telemetry sync. And then we want to set the sync on the instance. Of course, we're going to have to define this. And then we have to define a configure method. And configure the telemetry. It's also a good idea to go ahead and do that here as well. So let's go ahead and do that. Okay, I think we're good here. Now, where was I? Oh, right, the test. So let's go ahead and grab our sync. And then let's see if a signal was recorded on our telemetry. And let's go ahead and run this test. Okay, our test failed, and I think I know where we went wrong. We didn't actually record a signal. So if we go here, nowhere in here are we saying that we recorded a signal. So let's go ahead and do that. And let's go ahead and test this. Oh dear. Let me go ahead and see what's going on here. Oh, I think I know what happened. The problem is that I'm not actually actuating the class in question. So that's a problem. All right. I'm kind of a doofus. Let's go ahead and set up our controls. Okay, let's go ahead and see if that works. And it works. That sure was a long journey. But we're not done. We want to go ahead and test for recorded attributes. So we have a recorded signal. And now we want to test for recorded attributes. So the way we do this is with a similar predicate. It's similar, but when you use the record, let me go ahead and go there. When you use the record macro, it automatically creates a recorded, whatever the signal is, a predicate for us to use. And with that, we can test for the data that's sent into it. And of course, this test will fail because we're not actually sending anything into our telemetry sink. So let's go ahead and do that. So inside here, we send telemetry data, and we want to send in our to, from, and subject. Let's go ahead and test this. And it looks like it passed. And let's go ahead and do the rest. Now we have our tests, and let's go ahead and test this. And those passed. Excellent. So now we have some observability into the class's execution, but we don't want to grab the telemetry sink every single time we want to observe the execution of the class. So what I like to do is create a custom-made predicate for this use. So we'll go in here and create a new test. A lot of this will be similar, so we'll go ahead and just grab all of this. What we're not going to use is the sink, and we're not going to test for signals. Okay, so let's write a test to test our predicate method. So we have some scoping errors. So let me go ahead and change this. So of course this test is going to fail because we haven't actually coded the predicate method. So let's go ahead and do that. We're going to put it inside the substitute. And this is going to accept a block. We'll be using the telemetry sink to inspect and observe the class's execution. So this conditional is here so that if a sent signal was not recorded, we don't go ahead and continue. And if they don't have a block, we also don't continue. And now let's go ahead and use that block. We will want to pass in the telemetry data into the block so that we can use it later. Now let's go ahead and test this. And it seems to have worked. Now we can go ahead and code the rest of our recorded attributes into our sent predicate. And I think we're done here. Let's go ahead and test. Oops, something went wrong. Ah, I see. We have to actually pass in each of the variables that we're passing in. And for this, sent from, sent subject. And I think with that, let's test this. I'm pretty sure it will be successful. Yes. So we've coded a sent predicate, and we'll be able to use this in the future when we're testing whether our inert substitute was actuated. We've now built an entire SMTP library that we can observe the internals of and control as a dependency for other components and services to use. We'll be using this library extensively in many projects to come, but more importantly for our welcome email component. And I think that's it for now. Be sure to check back next week for part 2. The code will be available on GitHub if you need it. If you have questions for me, be sure to check out my website, josephchoe.com. You can also message me on Twitter, GitHub, and so on. Thank you.